Okay, guys, in this video, we are going to take a look at one of the most important problems in Calculus 3, and that is finding the equation of a plane containing 3 points. Now, 3 points cannot be collinear, meaning that they cannot all lie on the same line. If that happens, then we have a unique plane that goes through the 3 points. Okay, so let me show you how to do that, and this is a must-know for any Calculus 3 student, okay? All right, so there are your 3 points. The first thing you do, okay, let's call them something. Let's just say this is A, this is B, this is C. Okay, so the first thing we're going to do is in order to write equation of a plane, so here's how it looks like. We have to have a normal to the plane. So let's call it N. And let's say that this normal has A, B, C lowercase. Okay, those are the components. And then we also should have a point x0, y0, z0 on that plane. So just imagine you got a plane, which is like a piece of paper. You've got a point on the plane, let's call this P or whatever, and we have normal to the plane. So normal to the plane is a vector that is perpendicular to the plane. Okay, so it's going to be something like that. Okay, so that's vector N. And then point P, by the way, could be anywhere. It doesn't have to be right there. It could be just here somewhere, whatever. All right, so what is it going to look like? So equation of a plane looks like this. A, which is the x component of the normal vector, x minus x0 plus b, y minus y0 plus c, z minus z0 equal to 0. So that's your equation of a plane, okay? Now, what do we know here? Do we have a point on the plane? Well, actually, yes. We actually have 3 points, A, B, or C. So take your pick. Whichever one you want to pick, you can use for x0, y0, z0. In the end, because you're supposed to simplify, the simplified format will pretty much should be the same, except for possibly a multiple or something that you can just divide the whole thing by. So we do have a point. We have 3 points. But what about normal to the plane? Well, for that, we need to have the following idea. So when you have 3 points, so A, B, C, and let's say you're connecting these with the vector, and let's say you're connecting these with the vector. So this is, let's say A, this is B, this is C. How do we find a vector that's perpendicular to each of these vectors? So maybe you know that that's actually going to be the cross product. And that's how we can find that vector n. Okay, so we're going to find the cross product of, let's say, AB and AC. And once we get that, we have our a lowercase abc thing. Okay, so let's see if we can find vector AB first. So we're going to subtract the coordinates of A from B. So that's going to give us -6, 7, and -7. Okay, then we are going to find AC. So subtract the coordinates of A from C. So that will be 3. -3 subtract -2, it would be -1. And 0 subtract 2 would be -2. Okay. Finally, we want to find the normal vector. We want to find the cross product. So this is going to be I, J, and K. And then we're going to, by the way, the order here doesn't matter because you know, you can change the sign of the whole thing, but then you can divide by a negative. So in the end, it'll be the same. So this is what we got, right? So this is our normal vector. This is our n. Okay, so let's go ahead and see if we can find the cross product. So to do that, we're going to cross out. First, we're going to cross out the first row, first column. And then we're going to multiply the diagonal elements and then subtract the product of the other two. So our ith component, let me write this here. So this is going to be n. Ith component is going to be -14, subtract 7, right? Because -7 times -1 is going to be +7. Okay. Then the next component is -j. And so what do we do here? So let me move this a little bit away and move this here. Just this one. Oh, it doesn't let me do that. Come on. Okay. So now the next one is the j. Always remember the j comes with a minus. So this will be 12 subtract -21. So this is really going to be +21 plus k. So what happens with k? So here we want to cross out the k column, right? So when we cross that out, then this guy is going to be here. Doesn't want me to just select the red. Now we did that. Thank you very much. All right, so then the kth component is going to be -6 times -1 is 6, and then subtract 21. Okay, so I hope that I got -14 minus 7, so that is going to be -20. Okay, 14 is 21. Okay, then it's going to be minus 33j, and then minus 21 minus 6, I think that's 15k. Now we do want to check our work, and by checking our work, we need to make sure that this vector is orthogonal to each individual vector, which means that we should find the dot product. Okay, so let's go ahead and check that out. Let me just clear all of this. So the vector I got, let me just write it down. And don't worry that Desmos is complaining. I need to check to make sure that it's going to be orthogonal to each vector that I was crossing, right? So this is the first one, and that's the second one. Okay, so let's do the verification. So first we're going to multiply by the first vector, and this is the dot product. Hopefully you already know how to do that. Okay, so that's 0, and then we're going to do exact same thing with the second vector. Okay, so that's also 0. So that tells us that we found the cross product correctly. And then now what remains is just simplify the equation. So we got A, so this is your A, this is your B, and then this is your C. So you're going to have -21 x minus x0. So what is x0? So x0, I can take this as 2, -2, 2. Okay, so x0 will be 2. Then minus 33 y minus -2, which is actually plus 2. And then minus 15 z minus 2 equal to 0. Okay, so generally we are done. However, your teacher will probably say, okay, this is not the final answer because they want you to simplify it. So you're going to have to distribute and you're going to have to pretty this up, okay? Because in the end, the equation should look like this. Ax plus by plus cz equal d, okay? So let's see. So this is going to be -21x plus 42 minus 33y minus 66, then minus 15z plus 30 equals 0. Okay, so we already have these terms, right? So that's fine. We just want to simplify the numbers. Okay, so to simplify the numbers, we are going to, let me clear this, take 42 minus 66 and add 30 to that. That's going to give us 6. So plus 6 equals 0. Okay, so this is my final answer. You can also leave the 6 on the left-hand side or move it to the right-hand side, doesn't matter. But what I should do is verify that each point, so before you submit your work, you must verify that each point that you started with, and so let me write them down, satisfies the equation that you found. Okay, so I'm gonna just write down the points. And I'm gonna plug them into this equation and see if they work. So first, let's start with the first one. Okay, so that gives me 0. Okay, so I just checked the first point. Now I'm going to check the second point. So plug in the coordinates of that one. I also get 0. And finally, I check the last point. And I also get 0. So that means I'm 100% know that I'm correct. So they can't tell me I am wrong. By the way, you could have divided the whole thing by 3. That will also give you the right answer.